Sketch the graphs of y equals x minus 3 and 2x plus 3y equals 16. Let's think about what these two graphs look like. So they're both linear graphs, first of all, because there's no squares or multiplications of x and y's. So we've got two linear graphs. The first one, y equals x minus 3, is in y equals mx plus c form. The y-intercept at minus 3, a gradient of 1. So it's going to come up something like this, cutting through at minus 3 there. The second one, 2x plus 3y equals 16, is not in y equals mx plus c form. We could convert it into y equals mx plus c form, or we could use the cover-up method to work out where it crosses the axes. Cover-up y's, 2x is equal to 16. So when y is 0, x has got to be 8. So it's going to go through at 8 on this axis here. Cover up the 2x. When x is 0, 3y is equal to 16. So y is equal to 16 over 3. So up here somewhere. So this straight line comes through like that. Find the point of intersection of these two linear functions. How many different ways could we do this? So, first of all, if this was a calculator question, we could do this in our graphical calculator. That would be one method. We could plot these two graphs in our graphical calculator and find the point of intersection. Alternatively, we could draw and plot the graph precisely and try and find it that way, which would work if this is a whole number, but if it's not, it's going to be a bit tricky. The other way we could do it would be to solve these simultaneous equations, and there are two approaches we could take to doing that. We could do elimination. Elimination is setting up this equation as something, let's say x minus y equals 3, rearranging that one, and 2x plus 3y equals 16, and then solving these by eliminating. So multiplying the first one by 2 or 3 so that the x's or y's are the same. If I multiply the first one by 3, I'll get 3x minus 3y equals 9. And then adding these two equations together, I get 5x equals 25, x equals 5. And then substituting back into the first equation, 5 minus y equals 3 means y is equal to 2. So that gives me the coordinates here are going to be 5, 2. Alternatively, I could have solved these by using substitution. Given that I know that y is equal to x minus 3 and 2x plus 3y is equal to 16, I could substitute in this into the second equation. So I get 2x plus 3 lots of x minus 3 is equal to 16. So that's 5x minus 9 is equal to 16. 5x is equal to 25, which gives me the same result of x equals 5, and then y is equal to 5 minus 3, which is 2. I've got multiple ways I could approach this depending on the scenario to be able to solve this and find the intersection of these two linear functions.